Good morning, ladies and gentlemen, and welcome to the lightning talks. These are brief 5 to 10 minute talks that may or may not have been written here at the conference. First up is Rob Brincheno from the University of Cambridge, and he is going to ask the question, what is LoRaWAN?
Hello, testing, 1, 2, 3, hello. Okay, yeah, this was the original talk that my boss wanted me to give, Ed Your Own Certificate Rollover, something that he found very exciting. I didn't think it was so exciting, and Shirley agreed with me. So instead, we're doing, what even is LoRaWAN? Because that's one of the things that I've been spending some time on over the last couple of years. We've got some science projects going on with LoRaWAN in Cambridge. You might have heard the word LoRaWAN. You might know a lot about it, in which case, I'm very sorry, because this is really for people who've heard the word, don't know what it is, maybe want to know what it is, and I'm hoping that I can not just ask the question, but maybe tell you the answer. So firstly, some things LoRaWAN is not. It's not LoRaWAN. Someone last night said, oh yeah, I know LoRa, that's that thing where you can do like surgery remotely. No, that's Lola, which is a lovely project, but it's not what I'm going to be talking about. So it's not those things. Another thing that it's not is high-speed internet superhighway access. So, you know, you're not even probably going to be able to browse the web using LoRaWAN. If you work out a way to browse the web using LoRaWAN, I'll be slightly sickened and curious how you did it. This is a post from RevK's blog that shows the time that he managed to get ADSL running over damp string. And ladies and gentlemen, I'm here to tell you that LoRaWAN can be that damp string. So it's slow. It's really slow. It's proprietary. Semtech made it. They patented it. It's got a weird name. It's made by French people. What is it good for? This is what the acronym stands for. Long Range Wide Area Network. That sounds like a useful thing, right? We like WANs. Long range sounds good. You may also have heard this acronym, LPWAN, Low Power Wide Area Network. And this is part of the reason that it's all a bit confusing, because we talk about LoRa, we talk about LoRaWAN, we talk about LPWAN. So hopefully I'm going to break down a little bit of what the difference between those things are. A little bit more about why it's interesting. It's actually really long range and really low power. So you can comfortably do 10 kilometers in real-world scenarios if you stick a receiver at the top of a building. And the really low power thing is the thing that I think is super cool about it. This is like ultra low power. You can run a sensor off a little battery for years out in the field with no maintenance. It'll just sit there being a LoRaWAN sensor. You'll be getting data back off it. You want to do this because you like the Internet of Things, maybe. Not the kind of the smart home Internet of Things, maybe so much. This is about getting sensors out there and making smart places is my particular interest. So smart cities, smart fields, smart farms, anything where you probably don't have any infrastructure and you want maybe a lot of sensors. Why do you want sensors? Well, sometimes you want to take readings because data is helpful to your business and you want to do business better. So you want some data to know how to do business better. So in the olden days, we would send a guy around to take readings, and maybe, you know, he goes to every water pump every couple of days and takes a reading. But then, you know, we grow the business and we have more water pumps and it just gets worse and worse and worse. And now suddenly we're paying a lot of people to take a lot of readings. So LoRaWAN is a way that we're going to automate that. And we're going to do it quite cheaply. This is the type of board that you will put in a LoRaWAN sensor, and it's a LoRa transceiver. So now we're getting into the difference between LoRa and LoRaWAN. LoRa is your physical layer here. This transceiver is going to do LoRa, and it can do peer-to-peer communications with other LoRa transceivers without talking LoRaWAN. You don't need to worry about LoRaWAN at this stage. This thing is itself quite good. LoRa is a chirp spread spectrum technology, which you can go and find out about if you want. Some people claim chirp means compressed high-intensity radar pulse. I think that might be a bit of a backronym. It's a way of sending reliable signals over long distances with low signal strength, basically. This signal is starting off low frequency and it's spreading out to a higher frequency. And this allows us to do some quite clever maths to receive signals very reliably. So yeah, you can do peer-to-peer LoRa to LoRa without worrying about LoRaWAN, but you don't have to stop there. You can do more interesting things to make something more like the networks that we're used to working on, because peer-to-peer networks aren't desperately scalable, although they have their uses. And you can have a whole lot of fun playing with peer-to-peer LoRa networks and mesh LoRa networks. So we're going to add a gateway. These gateways are also quite cheap. This is one that's just come out this year, or coming out this year for a Raspberry Pi. You can stick a hat on your Raspberry Pi and use that to start doing real LoRaWAN stuff with these cheap sensors. So, you know, sort of $10 sensors, $100 gateways. If you want to start putting gateways outside, then they're getting a little bit more expensive. There's some disruptively priced gateways coming out now. And these things allow you to connect to multiple sensors at once, is the most fun thing about them. And they allow you to bridge your LoRa to your internet. So you can think of LoRaWAN a little bit like a Mac if you're thinking of LoRa as your physical layer. And it's described by Semtech in this document here, which is a great place to start reading if you want to know the technical details about how LoRa networks work. This actually is slightly more complicated than just a Mac. It's specified by the LoRa Alliance. They will make lots of different standards about how this all works and tell you about Class A, Class B, Class C LoRaWAN networks and describe the details of how that works in a sort of an internet scenario. So this is a picture of a typical LoRaWAN network. We've got the bit that I've talked about so far on the far left of this. The bit on the middle is more interesting about how you actually get data off this stuff over the internet. This picture comes from the Things Network. They're one of the groups of people that will provide you backhaul, and the Things Network will provide you it for free. They're a community network. It's another whole other talk. It's really interesting if you want to set up a community network or get involved in it, because you can buy your own gateway, your own sensors, hook into the Things Network, and start doing LoRaWAN yourself if you want, for no money. If you're a bit more interested in doing things on a professional scale, then there are companies like this OrbiWise company that will sell you network services. You can also buy the Things Industries network, which is a bit sort of a way to graduate from the Things network into something a little bit more professional in theory. Or you can run your own thing. You know, the Things Network stack is available. It's open source. You can run it yourself. You can run the LoRa server project yourself if you want, which is another free LoRaWAN stack. And it's a very useful way to turn a bunch of these guys from being powered by people to powered by batteries. So that's all I've got to say about that.
Thank you, Rob. Does anybody have any questions for Rob while Craig is setting up? Sir.
Do you have any issues with your information security people in a gateway in your network?
Not so far, but they probably don't know I'm doing it. The interesting thing about that probably is that, sorry, this is yours.
No.
Oh, you're not, okay. You're not actually providing internet access to the end devices. So it's not such a problem, potentially. I wouldn't say that you're actually violating Jisc's terms of use by allowing devices to go through your network because they can't get an internet connection. So I think it's okay. And also, Jisc love LoRaWAN, and they're doing their own Things Industries thing. So I think you're probably okay.
One more, yes?
What frequencies are they using?
Oh, yeah. So in Europe, the standard frequencies are 433 megahertz and 868 megahertz. The frequencies are slightly different in America, but if you go out and buy that sensor that I showed you just now, that transceiver, that's an 868 megahertz transceiver, and most of the gateways that you find for sale should be supporting 868 megahertz. And that's one of the reasons that we get such good penetration and signal propagation and stuff, because we're not competing with wireless. Yeah.
One more, quick one.
Just one quick thing, actually, significant rollover can be very exciting, as I found it.
Well, that's another talk for another time, maybe.
Thank you. Okay, our third talk is Craig Gallen. He's from Solent University, and he's going to talk about a practical application of LoRaWAN.
Yeah, it's great to follow on from that talk because I don't need to say a lot of things. So I'm a committer to OpenNMS, and I'm also a lecturer in network management and DevOps at Solent University. So how many of you have heard of OpenNMS? Great, fantastic. Those of you that haven't, it's a network management platform. It's been around for about 15 years, used by lots of people. But what I want to talk about is how we're moving that into doing stuff with IoT. So I'm going to do a little brief introduction to IoT, and then on to what we've actually been doing. So if you think about the emerging IoT ecosystem, which is partly what was alluded to here when we talk about different players who are coming in to provide MQTT gateways, LoRaWAN gateways, and the like. This is a diagram from the Telemanagement Forum that shows that there are many different vertical applications, but there's horizontal platforms that are being provided to provide different layers in the overall network. And we can see that there's a lot of very big players in there who are providing IoT platforms, so you can go out and use Amazon IoT or whatever, and it'll give you a good solution. But unfortunately, it's quite expensive when it begins to scale. So what could we do with OpenNMS to help in this space? And so if you look at the same sort of horizontal view of the world, you can see it. OpenNMS as a network management platform does very good data storage. It can also do event handling. It can also do correlation, all the sort of stuff you might need to do with an IoT solution. And it can store an awful lot of data in Cassandra or in Elasticsearch, and it can visualize that data and provide you ways to do something useful with it. So out of the box, we may have a solution here for an awful lot of IoT problems. So what have we done? Well, we've built a plugin for OpenNMS, basically, that allows you to connect to any MQTT broker and pull the messages out of the broker. Basically, if you know MQTT, you basically register for particular topics. The messages come out of the topic, and then we've created a parser that allows you to parse those messages, create new nodes in OpenNMS, and then visualize the data that's coming in from those nodes. So you don't even need to tell OpenNMS what nodes you have, you just need to tell it what topics to listen to. And under the hood, basically, we have an engine that allows you to connect to multiple MQTT brokers and then take the data as it comes off the broker and parse it in different ways. So we can handle basically any type of traffic that comes into us, any sort of JSON or XML or protobuf messages, we can pull in and think, okay, what are we going to do with that? Parse it into our own format and then pass it back into the storage engine for OpenNMS. So what does it look like then? Well, this is an application that we're doing in Southampton, where effectively we're getting air quality measurements from multiple sources, and we're displaying them on Grafana. And we also have ability to map devices as well on OpenNMS. So really, this is just the sort of things you might want to do with an IoT network, but you don't want to put a lot of work into developing your infrastructure. Well, in 20 minutes, you could set this up using OpenNMS, very easy. But the really interesting thing is the measurements API, which I'll show you next, which basically allows you to make a REST call to OpenNMS and ask for the data out of the system. Now, the interesting thing about that is that all of the data is stored raw in OpenNMS, and quite often the problem with sensors is you actually want to calibrate the data before you do anything with it. So could we do anything to actually take that raw data, and as we pull the data out, do calculations against it that calibrate it against whatever calibration we want to do? And in fact, OpenNMS allows you to do that, because you can see at the bottom of this slide, we've got the ability to do expressions, which can be quite complicated. And so as every value is pulled out by the REST API, then it actually does that calculation against the expression, and the values you actually get out or get displayed on Grafana have been pre-calibrated by whatever formula you want to run against that data. So that's basically the capability that we have out of the box that we can use. What has it been used for? Well, in North America, I have a colleague who's using it for mine tailings. So again, LoRaWAN network is collecting lots of data from little sensors around the tailings dam of a mine. If there's any movement in that, in the perimeter of that, then that potentially says that there's a fault occurring in the dam. And obviously we saw in South America the disaster that happened whenever one of these dams burst. So he's using this technology to actually measure the dam and make sure the dam is still working. In Southampton, we're using it for an air pollution study. So Nesta is funding a project in Southampton. At the moment, we've only got a very small number of sensors in a small area, but we're doing that as a pilot, and hopefully we'll be able to scale up to 100 sensors and then provide that technology to anybody else that wants to use it, basically. We've also used it for actually a different project entirely, really, where obviously Amazon has got its own internal CloudWatch capabilities, but we wanted to think, well, how could we get that data out of CloudWatch into something useful? And so we basically used Amazon's own IoT broker to listen on Amazon's event buzz to their own data that's coming out of Amazon CloudWatch, and then pass that back to OpenNMS using the MQTT. So again, a very simple way of integrating back into Amazon's CloudWatch. Could be done in other ways, but this works. So that really, in summary, is what we've been doing. We've got a credible IoT story now on top of OpenNMS, which basically means you've got a platform that's stable, that will be deployed in lots of areas and is very scalable, but now can also plug into your IoT network. It can monitor the IoT devices themselves, it can collect the data, and it can also monitor the whole infrastructure as well. So it gives you a complete solution for monitoring your IoT network from end to end, and it collects the data for you. It's a plugin, it's a prototype, but we want people to use it, give us feedback, contribute to it, and help us to make it better. So please spread the word and try it for yourself. Thank you very much.
Do we have any questions? Mark.
Not so much a question as a point of information. The previous speaker actually mentioned that Jisc is very excited by LoRa and doing some interesting work now. We've had 2 talks in the lightning session confirming that interest in the community. So it's great that we had a knowledgeable and engaged colleague that was developing this area for Jisc, who has now left. So it turns out that LoRa has joined my portfolio of responsibilities. So if there's anyone in the room who's interested in finding out more about Jisc in LoRa, or if there's ways that Jisc can support the 2 activities we've just heard about, please get in touch with me, and I will attempt to fake a sensible response and then go and Google what you've said. But yeah, Mark O'Leary is for anyone that's interested in Jisc's side of the LoRa story.
There's also a LoRaWAN talk in the network research session tomorrow at 10 a.m. I think. That will tell you how you can set up your own test bed.
Fantastic, thank you. Any questions now?
I'll ask a question myself because you guys may have the answer. One of the issues that we've had at the university is if students actually want to do MQTT and connect to Amazon's MQTT broker, that actually isn't allowed by our firewall, and they're claiming that this is a Jisc issue. So kind of points to your question that was asked earlier on, but as we do more and more of this stuff, it's going to become more of an issue in terms of connecting to wide area networks using MQTT in a way that's secure and monitored, but at the same time, actually allows us to do what we need to do.
I think my response would be leave it with me.
Okay.
Okay, thank you, Craig. Thank you. Our next speaker is Matthew Newton, and he's going to give us a Freeradius update.
Hi everybody, so yes, brief Freeradius update. I thought it was a good opportunity to go through what's been happening. And I know a lot of people are using Freeradius still for their edge roam setups. So version 3 is still the current version, has been for 3 or 4 years now, I think. Version 3.0.18 was released a couple of months ago, a few weeks ago, and there have been issues with systemd with that, which we know a lot of people have found. That is now being fixed. It was fixed fairly rapidly, actually. And version 3.0.19 will be released this afternoon. So if you're running version 3 of Freeradius, then that's something to look out for in a couple of hours' time. And the new version will be released. Version 2 is still end of life. It was end of life last year, and that remains to be the case. So if you're using version 2, then now is still a good time to look to upgrade to version 3. And along with that, also version 4, unfortunately, is still in development. And as along with a lot of these things, it takes quite a long time to get something out of the door. But it's moving on. There's a lot of good features and things going in there. One of the, or a couple of the features on that is move to asynchronous operation. So when you're calling modules in Freeradius now, rather than a call going off to a module to talk, say, to a database, and that blocking, waiting for the database to complete, and then finally when the database responds several minutes later, well, hopefully not minutes later, going back and releasing that thread back to Freeradius, then the modules now will then send off a request off to the database. Then the module is immediately freed up to go off and handle other requests and radius requests that come in. And then finally, when the response comes back from the database, the module can pick up from where it was left off and finish that previous query. So often the case where your Radius server is limited by the databases behind it, because the database is always slower, but it looks like it's the Radius server that's got the problem because the Radius server is the one that's blocking. With Freeradius 4, that's now moved, and it's very obvious now that it's the database that's got the problem, and Freeradius can still keep working on new stuff that's coming in. And another development that people have possibly seen is that Radius itself has now actually been moved, is no longer actually the core part of Freeradius. So whereas it was a sort of event processing software with Radius is the main thing, Radius is now just a plug-in module on the side, and other things can be plugged in as well as Radius, and that has been completely decoupled. The dictionaries that go with Radius are now pulled out of the core as well. They're tied to the different protocols. So one of the other protocols is DHCP, and no people have talked about that before and seen it, so that's another option. And although that's in version 3 as well, it now just sits alongside Radius in version 4 and can be used independently. Obviously with version 4 it's not released yet, it's still the master branch in GitHub, use it at your own risk. But there are several large companies that are using it under support, and it's being hammered and is working quite well in certain situations. So I mentioned a couple of those around the DHCP side, which is obviously not Freeradius, but it is Freeradius, it's not Radius, but you might be interested. So one thing I was involved in last year, using Freeradius 3, and it was just a DHCP project, so there's no Radius in it at all. Assigning static IPs in this case, and they were coming out of an open LDAP database. So it's a very resilient setup if you can do just static IPs for your setup. Push the entries into the master LDAP database. They just get replicated out to the consumers, which have just got a Radius server sitting next to them. Queries that come in, it doesn't matter which one you hit, you get the same answer, and it's crazy fast when you try it. Another project that I've been looking at recently is both Radius and DHCP on the same server, so you can run Freeradius, just run Radius and DHCP side by side. That one's backed by a Redis database, which works really well for DHCP pools, which obviously is what a lot of people do with DHCP, and comes up with very fast responses on that. And then also Postgres on there to do extra information and user logins and things with Radius. Monitoring with Elasticsearch on that one, which is nice because then you get nice, pretty graphs of all the things that are happening and can query the data with that. So that's a couple of situations where DHCP is in and being used alongside Radius, and both play quite happily next to each other. Some encouraging reports we've seen with DHCP. I've heard somebody has tested it and compared a lot of other DHCP servers against it, and quite happily that we found out that, and this wasn't commissioned or anything, this was just somebody who said we've been playing around with it, and that Freeradius with Redis backend, I believe it blew everyone else out of the water, but it was significantly faster, so that was quite a nice thing that we heard on that one. And of course, with your options with DHCP is with Freeradius is that you can pretty much put any database you like behind your DHCP pools. You're not limited to something that's built into the software or whatever. So if you want to have a highly resilient database architecture behind your DHCP server and have multiple DHCP servers in front, then that's obviously something you can do, whereas with quite a lot of other DHCP servers, you might be limited maybe just 2 DHCP servers that replicate between each other. So you've got a number of options there. So that's just some of the ways that things are going, some of the developments. Finished that one. Then just a small mention on the end of it is this is wearing a completely different hat. But another one of the things I do these days is some of the training for Jisc and their Edgerome courses. So just a bit of a plug, especially if there's new staff or people doing Edgerome in universities now and haven't been on the Jisc training, then it's well worth going on and learning about how Edgerome works and things. And the training team are downstairs here. They've got some sticky campus table things which you can sort of play with, and they're demoing off, which is quite nice. And they've also got a survey they want people to fill in with a prize of a robot. So I thought I'd mention that in case people like that. So that's me done.
We have one more bonus talk, and it's going to be Rob again. And he told me this was a secret, so I'll let him introduce you to the secret.
Right. Hello. So I thought I'd give this talk anyway, as I saw the list was a bit short. And yeah, it was quite fun. It was an interesting situation that we found ourselves in, and it's one of those things you see on clickbait on the internet, one weird trick that will help you if you need to do a certificate rollover that maybe you can rip off from us. We found ourselves in this situation at the start of the year, having had the same eduroam certificate for years and years and years. We suddenly realized, oh no, it's expiring. This is the certificate that lives on your Radius server, yeah? So when you're doing eduroam authentications, the clients need to trust that server. And the certificate that we had in place was going to change. We needed to do something about this, and we saw this as an opportunity actually to improve the way that, firstly, we handled eduroam security, and secondly, we were going to be able to handle the certificate rollover process in future. So what's this about security? What's the problem with eduroam security? Well, if you do EAP-TLS, there really isn't a problem. It's brilliant. If you don't do EAP-TLS, you're probably doing what we do, which is EAP-MS-Chat v2. And it's okay, but it's got some problems, particularly with Android clients. With Android clients, we found that Android clients will just trust any server certificate that's signed, no matter what the server's called. If you tell it to use a server certificate that's signed by a public CA, it will trust any public CA. So you can go and make your server called whatever you want, run a rogue AP, and Android clients will connect to it willy-nilly and give away all their authentication credentials to it. So that's brilliant. And we thought that this is actually an opportunity to fix that, because Android clients actually do have a way of connecting to eduroam securely if you give them a copy of the server certificate, and if it's a self-signed certificate, then they'll actually make a really nice secure connection to the server. So these are the problems that we have. The certificate's changing. We need to tell people about what to do with the new certificate and stuff. Android people really need this self-signed certificate to make a secure connection, but everybody else in the known universe hates self-signed certificates. But we have a secret weapon, which is Freeradius. And because we run our own Freeradius server and we hack Onlang and things like that, we can do magic with Freeradius. No matter what the problem that faces us, we can solve it in Freeradius. And we solved this problem in a cute little sort of 8 lines of Onlang, which is right here. What we do is we let the eduroam clients tell us a different outer identity depending on what certificate they want the server to use when they're authenticating. So if you don't tell it a special outer ID, it'll use the old certificate and things keep working. But if you've read our instructions that tell you how to configure the new certificate, you will use one of the _public at cam.act.uk or _token at cam.act.uk outer IDs. So actually, we didn't roll over the certificate. We rolled over from one certificate to 2 new certificates, and the original certificate keeps working. So if you're an Android user, you can install the self-signed certificate on your computer, your Android device. You can call yourself _token at cam.act.uk, and everything works. If you're an Apple user and you don't want a self-signed certificate on your device because you don't trust us, then you can call yourself _public at cam.act.uk, and it also works, and you're authenticating against a known CA route, so it's all brilliant. And all we had to do, he said glibly, was tell the users that this is how it's going to be when they start using the new certificates. So we say, this is going to change, everything's going to keep working for you for now, but once the new certificate is live and the old one is deprecated, the old one won't work and you will need to have followed these instructions. But we could have like a couple of weeks where they were reconfiguring their devices quite happily with the old certificate still working, and these instructions are on the web. And the help desk moaned about it. But of course, they moaned about everything. And actually, we had about 5 problems that we couldn't solve. And it's mostly completely fine. So that is how you do EduM certificate rollover like a pro. Okay.
Thank you, Rob. Are there any questions? No? Yes, go on then.
I could give the other exciting example if you like.
Yeah, please.
Which, everyone says not to use public certificates for Radius, and that's good advice. This particular case that somebody didn't follow that, they did use a public certificate for their Radius server, and happened to come from Symantec, who had a few issues a while back. Put this, this came up for renewal, which took longer because Symantec, and put the new Radius server certificate on, which happened to have a different root CA. They're doing ETLS, and of course with Windows machines, you tie the Radius profile to which root CA you're going to use. So that turned into a bit of a panic, because suddenly you've got a shed load of Windows machines which have got less than a day before their certificate expired, or over a weekend, and suddenly none of them will connect, because the root nothing. Changing a Radius server certificate is no problem at all, but changing the root CA with no control over it, because obviously it's a public CA if you go down that route. Rather interesting.
Yeah, so I glossed over some details about that. There's another problem with using a publicly signed certificate, which is that they often don't give you them for very long, so you have to do this process very frequently. And yeah, we'll probably be making _public2 at cam.act.uk in the not too distant future. And another really annoying thing is, if you install this certificate, I think on Windows, by default, if you were to install the self-signed certificate, that would want to install it in the Global Trust Store. So it would want to start using that self-signed certificate for your web browser, which you probably really don't want. I mean, the idea that we're just giving you a certificate to install that's then going to be trusted for everything, I don't like a lot. So this is a way to get a bit more granularity in that as well. We probably want to give some more specific instructions for any security-conscious users.
There's definitely a private CA is the way to go.
Okay, any more? Any more? In which case, that concludes the lightning talks for another year. I'd like to thank everybody who's taken the time to make a presentation today. I'd like to thank the AV techies for making this all work so smoothly, and thank you for coming. Thank you.